Welcome to aminacademy.com. In electrical engineering, let us discuss about electrostatic, that is static electricity. We know that electric current, electricity in motion. What is electric current? Electricity in motion is an electric current. Now we will discuss the behavior of static electricity and the laws governing it. In fact, electrostatics is that branch of science which deals with the phenomena associated with electricity at rest. In generally, an atom is electrically neutral. That is, in a normal atom, the aggregate of positive charge of protons is exactly equal to the aggregate of negative charge of the electrons. If somehow some electrons are removed from the atoms of the body, then it is left with a preponderance of positive charge. It is then said to be positively charged. That means some negative charges removed from neutral atom, then it's called a positively charged. If on the other hand some electrons are added to it, negative charge out balance the positive charge and the body is said to be negatively charged. In brief, we can say that positive electrification of a body results from a deficiency of the electrons, whereas negative electrification results from the excess of electrons. The total deficiency or excess of electrons in a body is known as its charge. What is static electricity? Further detail. Static electricity is the result of an imbalance between negative and positive charge in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. One way to discharge from them is through a circuit. That is, static electricity is the result of an imbalance between negative and positive charges. Here, for a good example for charging is static electricity is lightning. Here, look at this. These are clouds. Some clouds have positive charge, some clouds have negatively charged. In a storm, clouds move over each other. This causes them to become a charge when electrons are transferred between them. This causes them between them since the ground is neutral. The negative charges from the cloud jump to meet the positive charges on the ground, creating a giant spark. That is a current from transfer of charges. This phenomena is known as lightning. Here, charges also travels between the clouds. The negative charge built up on the cloud is attracted to positive charges on the ground, causing lightning. Lightning is caused by the build-up of charge in clouds. Sticking a balloon on a wall. Suppose rubbing a balloon on a woolen jumper transfers electrons onto the balloon by friction. Then the balloon becomes negatively charged. The balloon is now negatively charged, whilst the jumper is left positively charged because it loses electrons. The wall is still neutral. However, when the balloon is placed near the wall, the positive charge in the wall are brought to the surface because they are attracted to the negative charge of the balloon. Since positive charges attract, the balloon sticks to the wall from only the electrostatic attraction. Charged foam picking a paper. Static electricity can be observed when running a plastic foam through your hair, dry hair, then placing the foam near small pieces of papers. What happened? The foam becomes the charge by friction from the hair, so it is left with negative charges, so the electrons are transferred to it. This also means the hair strands become positively charged and they begin to repel each other. Pieces of paper are neutral, but as the comb comes close to them, the positive charges are brought to the surface of paper and are attracted to the negative charges on the comb. Therefore, the papers stick to the comb through static electricity. Look at here. Comb very first is a neutral. After rubbing your hair, dry hair, what happened? It's a negative charged comb. It became a negative charge. That means some electrons from hair to comb, it's passed. Then positive charges from the paper are attracted. Small pieces of papers are already neutral. Positive charges from the paper are attracted to the comb, so the paper stick the comb. That means a negatively charged comb can attract small pieces of paper. Earthing is another example. Earthing, this is the process of removing excess charge by the movement of electrons. This is used when an object or a body is charged and the charge needs to be removed to avoid sparking. It is sometimes called grounding. Big vehicles run fast in the road because of air friction. It is somewhat charged. So after charge, the body must be earthed to the ground to become a neutral. Otherwise, sparking possible. The earth can be imagined to be a giant reservoir of electron. So it can give and take excess electrons. Earthing is done by connecting the charged object to the earth by a conductor. A conductor is used since charge can flow through it. Unlike an insulator, that conductor passes through the excess electrons from the body to the ground. If a positively charged object is connected, electrons will be attracted up through the conductor and to the positive charge, cancelling them out, because Earth is a very giant, so it's easily attract excess electrons. This is because of opposite charge attracts, that is Earth attracts electrons easily. Now look at here, this figure as here is a Earth. Opposite charges attract each other, this conductor. So look at here, due to the body is a conductor, it becomes positive charge after earthing, that means connected to the ground. So it is electrons are attracted to the earth, so it becomes a neutral. That means the body becomes neutral. Absolute and relative permittivity of a medium. The base value of the permittivity is assumed to be the absolute permittivity of vacuum. The ratio of the medium's permittivity to vacuum's absolute permittivity is the relative permittivity of that medium. Now, here let epsilon 0 is absolute permittivity. Its value for vacuum is 8.854 into 10 power minus 12 F over meter, Fermi over meter. Relative permittivity, that is epsilon r. Relative equal to 1. There's no unit because it's a comparison of two permittivities. Being the ratio of two similar quantities, ER has no units. Now, take any other medium. If the relative permittivity as compared to vacuum is ER, then its absolute permittivity is other medium, absolute permittivity is epsilon, which is equal epsilon 0 into epsilon r, F over m. For example, relative permittivity of mica is 5, then its absolute permittivity is, suppose for mica, for a substance mica, epsilon equal to epsilon 0, which is equal 8.854 and 10 to the power minus 12 into 5, because relative permittivity is 5, so which gives, for multiplication, it is 44.27 into 10 to the power minus 12 F over m. We have done. Please subscribe our YouTube channel.